Hi, my name is Fred Newman. I'm the owner of the View Camera Store, and today I'd like to talk about BTCS film testing, the procedure that I do for you. And this is actually a film test that I have done, and you can see the dates here. Basically, first we record the family curve film details right here. So this is the date of the film test. The film that I was working with was Ilford HP5 Plus 4x5 sheet film. We enter the film speed that's actually on the box. It's ASA 400. The developer that I use was Ilford DDX. The dilution of the developer I use is 1 plus 9, so that's 1 part developer, 9 parts water. I process all my film at 75 degrees. It's kind of warm in Arizona, so it's just easier to do that. The test was done in BTCS tubes, and there are 2 ounces of developer in each of the tubes. And the notes are, this just put my initials here so they know the test was me. Now, that's all done. So now we have the next chart, and if you notice here, the first column is step tablet, and then the film is processed for 4 minutes. Another sheet is for 5.5 minutes. Another sheet is for 8 minutes. Another sheet is 11, and another is 16. And you'll see here it says on this side steps 1 through 21. These are actual density readings of the 4x5 step tablet, and actually the density starts at 0.04. Then next is 0.19. These are like 1/2 stop. So this is actually a 21 step tablet, and it's actually 10.5 stops because each of these steps is 1/2 stop. And then these are the individual density readings for the 4-minute tests for all 21 steps for each of the 5.5, 8, 11, and the 16. And what the data actually looks like is right here. And I'll make it a little bit easier to see if I put the points in. So these are all the 21 steps that I've done, actually entered into the program. And you can see this bottom one is the 4 minutes, 5.5, the 8, the 11, and the 16. And you can see they're fairly evenly spaced. We're doing a series with just like f-stop, so you should get a fairly even spacing in there. And you can see, as I say, you can see each of the individual points. Now, the reason we read the densities of the step tablet so that the curves are a little bit smoother, because sometimes they're not exactly what you expect. So these numbers down here are the densities of the step tablet, and these numbers up here are the actual densities that I'm reading off each of the individual film tests. Now, the next curve to look at is the analyze curve. Now this shows you all 4 curves, pardon me, 5 curves. So you got the 4-minute curve, the 5.5, the 8, the 11, and the 16. I like this chart because it shows you everything here. So at 4 minutes, we're a little bit less than a film speed less than 250, and a subject brightness range of about 10.5. And you can see the same here, 5.5 minutes, a little bit more than 250, and a subject brightness range of 8.4. And here we've got 320. 11 minutes is 320, a little bit more than 320. And you can see, so we've got film processing time, film speed, average gradient, and the subject brightness range. And let me show you here, because this one says family here. So we've got the individual 4-minute test. So you can actually see what each test looks like, the average gradient, the paper scale. We'll talk about that a little bit later in another video. But right here, as you'll see again, it says ES of 1.0. That's a typical grade for like grade 2 paper. One of the nice things about BTCS film testing is we enter the individual paper grade for your paper. In other words, your enlarger light source and the paper you're working with, or if you're doing contact printing, whatever the grade of the paper is, or if you're doing platinum palladium, whatever the numbers, this gets entered into here, and that will affect the actual film curve. So that's why this is very important to enter in. So we actually do each individual curve gets plotted. And you can see here all of them. And then we have the charts. So we start out with developing time, which you can see on the bottom here, versus subject brightness range. You can see the solid line is on the 7, so that's what we consider our normal. So for this film, developing would be about 8 minutes for normal. And these numbers later get exported into the Expo Dev program, but I'll go into that a little bit. So you can see here with developing time versus subject brightness range, developing time versus average gradient, developing time again at the bottom, developing time versus n numbers, and then effective film speed on the bottom here versus your subject brightness range, effective film speed versus average gradient, and effective film speed versus n numbers. So What's interesting is this chart, the average gradient chart. This is one of the charts that gets exported into your Expo Dev program, along with this chart right here, your film speed chart. So typically, this film is about the HP5 ends up being about a 320 speed film, which is pretty good considering. Now, that's what all the graphs look like. And if you look at the video on the Expo Dev program, you'll notice under File, you have Export to Expo Dev. And right here I've got my film, so I'll just correct this a little bit so it's easier to see. We don't need the developing. Actually, this will work here. I think that should be fine. And what's interesting is the charts here. One of the articles in our newsletter called DMAX in Volume 9, Issue 4, we discuss how Phil Davis calibrated all these individual information on reciprocity. So these charts here where it says you've got A, B, C, D, and E, this is the amount of film speed loss. So if this is your normal, an A film would lose 2 stops, a B film would lose about 3 stops, and a C would be about 3 2/3 and on. And these are developing time changes. These all came from our film testing procedure. So when we look at Coleman films, let's look at HP5 Plus here. So HP5 Plus in Ilford DDX would be an A3 film. So if we go over to, let's click OK. Let's look at the chart. So an A film is a film that loses 2 stops in reciprocity, and a 3, this is your little multiplier in terms of your developing time. So I hope this helps you a little bit understand what we do. Let me just cancel out of here. And again, all these data comes from your film test. So basically, all you have to do is, as I say, is process the film. I read all the densities of all these, 21 times 5. I put all those into the plotter program. So it makes the actual time of film testing, the amount of time it just takes you to process film. And let me just go over one more thing. If you were a roll film, let's just say this was roll film, and I'll do one of those later. I'm just going to put a little bit of flare in here, 0.02. And you'll notice it changes a little bit. So if this was a roll film, your normal developing time would be about 9 minutes and 20 seconds. And let's go to the film speed here. And your normal film speed would be about pretty close to 400. You might want to set your meter at 400 would be close enough. So we're going to go into that in another video. So this is just the first one in the series of film tests that I'm going to do for you. Okay, I'll go back to the data page. Thank you for watching. If you have questions, please email me. Thank you again.